Hi, in this tutorial, we will learn more on the value of limit as x approaches to positive infinity or negative infinity. Let's take a look at the theorems that we have to use. The first theorem is when x approaches to positive infinity and the function is 1 over x power n, the value of the limit will equal to 0. For example, if this is limit of a function 1 over x squared, and the x is approaching to positive infinity, the value of the limit is 0. It's also 0 if there's a number on top here or a number below here. Also the same case if the limit of this function is approaching to negative infinity, still the value is equal to 0. Remember the first step when you want to find limits. The first step would be substituting the value of that x into the axis of the function. But if let's say when we substitute that value of x, and for this example it's infinity, we get the value infinity over infinity, then what we have to do is we have to divide each term by x to the highest power of the denominator. A little bit of correction here, divide each term by the highest power of the denominator of x. First example, when we substitute infinity into the axis here, what you'll get is infinity power 3 is a very large number. Infinity times 2 is still infinity, plus infinity squared is infinity, minus 3 is infinity. And then below you get infinity power 3 is infinity, plus x is infinity, plus 2, still it's infinity. So infinity is a very large number. So when you substitute the value of the x, you get the value as infinity over infinity. Then what we have to do is we have to divide each term by the highest power of the denominator. So this is not the answer. So what we should have to do is we should start by writing down the question and then determine the highest power of the denominator of x. Look at our denominator, highlighted in yellow. What is the highest power of the x at our denominator? The highest power of x is x power 3. So this means we have to divide all of the terms at the numerators and also at the denominators with x power 3. How? Let me show you. Start by writing down the functions at the numerator and also at the denominator. And then divide each of the term with x power 3. 1 by 1. Next step is to simplify. Now to simplify, you see this is x power 3, divide with x power 3, we can cancel this off. And the next one, you can simplify this to be 1 over x power 1. And then we can also simplify this. When x power 3 divide with x power 3, what you get is 1. Remember, it's not 0. And divide x with x power 3, you get x power 2. And so on. Write your simplified version of the function. The first term is 2 because it's 2 times 1. And then the next term is we have 1 over x left. And then 3 over x power 3 at the denominator. The first term is 1. Next we have 1 over x power 2. And then the last one is 2 over x power 3. Now, whenever you see fractions with a number over x power 1 or x power 2 or x power 3 or x power of anything, remember this theorem. This theorem states that any number divided with x power n, when x approaches to positive infinity or negative infinity, the value of the limit is 0. So, in example 1, when we see that 1 over x minus 3 over x power 3, 1 over x squared, and 2 over x power 3, this means that we can use the theorem and simply let it equal to 0. So this will go, and this will go, all of that will go. Why is it 0? Because it's like substituting the infinity inside. So it's like 1 over infinity. What is 1 over infinity? Try to press your calculator. 1 over a very large number. Press it on your calculator and you get the value is equal to approaching to 0. So the only numbers left is just 2 plus 0 minus 0 over 1 plus 0 plus 0. You will have 2 over 1. Simplify this, your answer is just 2 for the limit. Now, example 2. Remember the first step of any limit, no matter what the x value is. Your first step is to try to substitute the value of x into the function. This is negative infinity. When you substitute negative infinity into the x, you get negative infinity. And then below is also infinity. So whenever you get the form of negative infinity over infinity, or infinity over infinity, or negative infinity over infinity, as long as it's just infinity over infinity, this means that you have to remember this step, which is to divide each term by the highest power of the denominator of x. What is the highest degree of the denominator? Look at the x with the highest power at the denominator. So the highest power of x at denominator is x power 2. Ignore the number 3 in front because we just focus on the x. Start by copying the numerator and also the denominator function, and then divide each of the term with the highest power of the denominator. And the highest is x power 2. So divide everything with x power 2. Remember, ignore that number 3 in front of x squared. And then you just simplify. Simplify this. X power 1 divided with x power 2 is 1 over x power 1. And then at the denominator, x power 2 divided with x power 2, it goes. You're left with number 3. And behind is just 1 over x squared. Please remember your theorem that I've showed you before. Whenever we see the form of 1 over x power something, or any number divided with x power something, is just equal to 0. So here we have that 1 over x. So when you substitute in 1 infinity inside there, it's 1 over negative infinity, and the value is approaching to 0. So here it's approach to 0, and also 1 over x squared will also approach to 0. So what's left on top here is just 0 divided with 3 minus 0. What is 3 minus 0? It's just 3. What is 0 divided with 3? You don't have to press your calculator for this. This is just 0. So the value of this limit is 0. Example 3. Remember, the first step is to always substitute the value of your x into the x's and see what you get. When you substitute positive infinity squared is positive infinity, plus with 4 is still positive infinity, square root positive infinity is still positive infinity. And then at the denominator, when you substitute in positive infinity, plus 3 is still positive infinity because positive infinity is a very large number. So when you're adding with 3, it's still a very large number. And your answer will be infinity over infinity. So this is not the answer. This is just one of the conditions which tells you that you have to use this method, which is to divide each term by the highest power of the denominator. Now let's look at your denominator. Denominator is here under the fraction. What is the highest power of x for the denominator? The highest power is x power 1. This means we have to divide all of the terms with x power 1. For the denominator, we know that we can divide each of the term with x power 1. But for the numerator, since this is a very large square root with a plus sign in the middle, we cannot simply just divide each of the term with x. This is wrong. Remember, because we have this condition. Square root of a plus b is not equal to square root of a plus square root of b. This means when we want to divide with x, we have to divide everything with x. Plus, the x cannot enter the square root because this is x power 1, not square root of x. Do take note that square root of a over b is not equal to the square root of a over b. But square root of a a over b is equal to the square root of a over square root of b. So that means if you want to simplify this x, you have to put this x into the same square root. And to do that, you have to use this property. But to use that property, x must be written in the form of square root of something. And what is that square root of something? Try to figure out. Well, x is equal to the square root of x squared. So we can change x with square root of x squared. And after that, the square root of x squared can enter the same square root as the numerator. So I'll be changing my x with square root of x squared, because square root of x squared is equal to x. And then we can also apply this property so that we can combine those two square roots to be one big square root. And then we can divide each of the term with x squared, like this. And then after that, simplify. X squared divided with x is just x power 1, and x divided with x is 1. And then write your simplified version. Remember your theorem. Whenever we see a number over x, then we can use this theorem, and the answer is 0. We can only use the theorem when x is approaching to positive infinity or negative infinity. And for this question, it is approaching to positive infinity, so the value of 4 over x, the limit, will approach to 0. And also the same for limit of 3 over x will approach to 0. So what's left inside the square root is just square root of 1 plus 0 over 1 plus 0. Notice when does the word lim and the x approaching to positive infinity disappears, or that we don't write it anymore. It's whenever there's no more x. Look at the latest step. This is just square root of 1 plus 0 over 1 plus 0. There's no more x, so we don't have to write the limit word and the x approaching to infinity anymore. Simplify this, you get square root of 1 over 1, and this is just 1. That's your value of limit for example 3. Let's look at example 4. When you substitute the value of x into the function, what do you get? You get the value is just infinity or just negative infinity, then you're still okay. But if you get infinity over infinity, or negative infinity over negative infinity, or any other form which has infinity over infinity, then you have to divide each of the term with the denominator of the highest power. And for this example, when you substitute in negative infinity into the x, you get negative infinity on top, because it's a very small number, negative infinity plus 1. And then you divide with negative infinity squared will be positive infinity, plus 1 is still positive infinity, square root positive infinity is still positive infinity. Remember, whenever you get this form, that's not the answer, it's just a trigger for us to simplify the function by dividing each of the term with the highest power of the denominator. What is the highest power of the denominator for this example? Look at your denominator. The highest power is x squared. But remember, it's not just x squared. Look at it. It is square root of x squared. Square root of x squared. And square root of x squared is a very interesting function, where this is actually the definition of an absolute function. Absolute function x is equal to square root of x squared. And remember, absolute function can also be divided into two cases, where x is positive and also when x is negative. When x is positive, this is only for values of x greater than and equal to 0. And when x is negative, it's only for the value of x when x is less than 0. Since the highest power of the denominator is square root of x squared, then we have to divide each of the term with square root x squared. Now, at the denominator, we have square root of x squared plus 1. divide with square root of x squared. We have to use the property of square root of a over square root of b equal to 1 big square root a over b, because it's easier for us to simplify the values. Put everything in one big square root and then divide each of the terms with x squared. Why each of the term? Because this is a fraction, and when you divide with one denominator, then you can separate it into two like this. What about your numerator? Look at the value. This is square root x squared. Even though you can simplify this and write it as x, but be careful. Look at the definition. There are two possibilities for the x. It can be positive x and it can also be negative x. So which one is it? To determine which one it is, you have to refer to the value of x that you want to look at. The value of x is x approaching to negative infinity. So of course, it's a negative value and it's less than 0. That's why we have to choose negative x to replace our square root of x squared. Now I will replace square root of x squared with negative x. After that, since this is a fraction, x divide with negative x and 1 divide with negative x. Separate it into two fractions. After you have separated all of the fractions, then you simplify. X over x is 1, x squared over x squared is 1. Okay, now why is there still the word limit here? That's because there is still x at this step. Next, remember the theorem. The theorem says that the limit value will equal to 0 if the x value is approaching to negative infinity and the function is a number over x or x power n. This means the value of 1 over x here will be 0 and the value of square root of 1 over x squared will also be 0. Simplify, and what you'll get is negative 1 over square root of 1, and this is equal to negative 1. Let's look at example 5. Your first step is to substitute the value of x into the function. When you substitute, you get infinity over infinity. Whenever you get that, please remember what you have to do next is you have to divide with the highest power of the denominator. And then look at your denominator. What is the highest power of the denominator? The highest power is x power 2. So divide everything with x power 2. At the denominator, you can divide each of the term with x power 2. But at the numerator, this is a square root. So you cannot divide each of the term with x power 2 unless you change x power 2 to be a square root of something, so that we can insert that value of something into that big square root. To apply the property of square root of a over square root of b is equal to square root of a over b. Now, how to find the value of something? Let's say you have no idea how to find it. You can just replace that with a. And let's say that a is the value that we want to find. So just leave a on the right side and bring square root to the left side. What is square root? Square root is power 1 over 2. Or to bring power 1 over 2 or the square root to the left side, remember, you just have to put power 2 on the left and also on the right side. Because when square root meets power 2, it disappears and what's left is x power 4. So a is equal to x power 4. This means we can let x squared as the square root of x power 4. That's the a that we have just found. Now we can apply the property of square root of a over square root of b equal to square root of a over b, and then we can put them in one big square root and then divide each of the terms with x power 4. Simplify. X power 4 divided with x power 4, x power 2 divided with x power 2 is equal to 1. And then to simplify this, remember the theorem. So we can see there's 2 over x power 4 here. When you find the limit as x approaches to negative infinity of this function, it will approach to 0. Also the same for 1 over x squared. The limit will also approach to 0 according to the theorem. And then what's left is just square root of 16 plus 0, divide with 1 plus 0, and the answer is square root of 16 and is equal to 4. Now example 6 is a little bit unique because there is no fraction here. So remember your first step. Try to substitute the value of your x into the function. You will get negative infinity power 5 plus with negative infinity power 4 plus with negative infinity power 2. Now you are not sure which one is bigger. So for this type of question, since there is no denominator is just equal to 1, then we cannot divide with the highest power of the denominator. But what we can do is, we can factorize. We can factorize the highest degree of x. And we can factorize it, put it outside. The highest degree of x for this function is x power 5. Put it outside. And the rest will be in the brackets. So what's left? When you have factorized x power 5, you're left with 3. And then there's still 2 here. But what about x power 4? If you have taken out x power 5, which is greater than x power 4, so to make it equal, you have to still divide it with x. How to get this x power 1 is like x power 5 minus with power 4. That's why you get x power 1. The same for the next number. What's left is 4. And then what about your x power 2? Still the same, it's just x power 5 that we want to take out minus with 2. So what's left is over x power 3. How to make sure that you have factorized correctly? To check that, you can simply just expand x power 5 times 3. Do you get the same? Yes. X power 5 times 2 over x is 2 times x power 4, and then x power 5 times 4 over x power 3, and you will get 4x power 2. Make sure all of the terms are correct after you have expanded. And that shows that you have got the correct factorization. If not, please do your correction. Now, after you have factorized x power 5, you can use the property of limits and split this into two functions. So whenever we have functions multiplied together, we can also split it into two limits multiplied together. Remember, you can apply the theorem whenever you see 1 over or a number over x or x power of n, then the value of the limit will equal to 0. So here you see that function. So this means these two functions, the value of the limits will approach to 0. So here what's left is just positive 3. And positive 3 is multiplied with the value of the limit for x power 5. So how to find this limit? This is the value of x, which is negative infinity. Just substitute that into your x. Negative infinity power of 5. And what is negative infinity power of 5 multiplied with 3? Negative infinity is a very small number. Multiplied with 3, still a very negative number. And that's your final answer. Thank you for watching.